Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, professors, morning. Welcome to the SEGTA, Sustainable Energy and Green Technology Applications. Let me introduce myself. My name is Syahril Mubarok. I'm the lecturer at Electrical Engineering, Faculty of Advanced Technology and Multidiscipline, Universitas Erlangga. At this time, I'm going to present one of the topic of the SEGTA. The title is the solar shelter to support electric mobility in Gili Island. Okay, without further delay, let's go through the uh, tutorial. Okay, first of all, um, let me introduce you about the Gili Island. Some of you maybe already knew about the Gili, maybe some not. Gili Island is one of the outermost island located in the Sumeneb, Madura, East Java, Indonesia. Um, the the area of the island is around 9.15 square kilometer and with 7,302 residents over there. Iyang has a great ecotourism potential, and but however, to increase the potential of the visitor to visit the island, it must be accompanied by the adequate infrastructure, such as the electricity and also the electrical energy resource. So until now, the um, electrical company in Indonesia called PLN, they provide two diesel power plant in that island. So as we know that the diesel power plant use the fuel oil so that it can how to say that so it's not a renewable energy. And the other problem is because there are two villages in that island, namely Bensamara and Balraas, and the electricity is distributed alternately during the day for the two village, so it will affect the flexibility of the community activities. This is become a concern for the tourism destinations, as the supply of electrical energy is something that must be maintained continuously. And Gili Island uh, has a potential for the new and renewable energy, uh, that is solar energy. The use of the renewable energy to support the tourism has become a positive trend recently. Many tourist destinations around the world are seeking to integrate the renewable energy resource as part of their sustainability practices. The use of the solar panels to produce the electricity, such as for the lighting or the charging station, um, uh, they can be used for uh, in the tourist destinations. So here, the Faculty of Advanced Technology and Multidiscipline (FDMM) from Universitas Erlangga um, has been implemented community services in the Iyang Island in March 2023. Uh, we implement a solar shelter um, for a charging station at one of the tourism place in the Iyang called Batu Changga. Yeah. The aim of implementing this solar shelter is to provide the electricity while the tourists explore the destination. The tourists can charge their device or mobile phone in the solar center without uh, any feeling to fear running out the electrical energy. Process, as we can see here, the process of installing the solar shelter was carried out by the TMM lecturer, the students, and also the local residents. So we was working together with the solar charging or solar shelter. Okay, here is the specifications of the solar shelter that we implement. So the solar shelter has the 15 watt peak mono solar panel and with acid battery 12 volt and 50 ampere hour. The capacity of the battery is 12 volt and 50 ampere hour, and it's also has the solar charge controller to charge the battery, and it has the inverter to convert from the DC energy from the battery to AC uh, electric energy. This solar solar also equipped with the 10 watt LED lamp. It has 3 unit AC 230 volt socket and 2 unit DC 5 volt sockets. And we don't just do an installation, but also the maintenance in the Iyang Island. So it held on the October 2023. So we went there for maintenance to ensure the solar shelter uh, and works well and the functions, and to ensure that it functions properly. So let's move to the basic idea of the solar shelter. So the basic principle of the solar shelter is about the energy conversion. So we use the energy from the solar panel and then store the energy to the battery, and also after that we use the energy from the battery and convert it to the uh, AC electrical energy 220 volt. So for example, in here, we use the solar panel. The output of the solar panel, it could be 18.57 volt. And it needs to use for 12 volt battery. I mean, we need to use the energy from the solar panel to charge the battery 12 volts. So we need a step down converter here. After that, from the battery, usually the inverter package it use the step up converter and also convert it from DC to AC by using the inverter. And on the other hand, for the 5 volt socket, from the 12 volt battery, we need to use the step down converter. And to provide 5 volt. Okay, let's discuss about the solar charge controller. Solar charge controller um, is used to charge the battery from the from the solar panel or the photovoltaic. And the SCC, the main task of the SCC is to maintain the charging voltage and also the charging current of the battery, uh, so that the charging so that they will not uh, the overcharging will not be happen. If the overcharging happen, then of course it will make the battery damage. And the other task of the solar charging controller is to uh, I mean to limit the charging current. If the battery reach a certain level of the uh, charge, then the controller or the solar charge controller will cut the charging process. So the basic circuit of the solar charge controller is the step down converter, or usually we use the buck converter to charge the battery. If you learn about the power electronics in electrical engineering field, uh, maybe some of you know about the buck converter. Buck converter is a type of the DC-DC converter that is used to reduce voltage from its input to its output. So the output is always less than the input, and the value of the output is proportional to the duty cycle multiplied by the input, and the duty cycle is always less than 1. So it could be 0.1 until 0.9. And as we can see here that the main component of the buck converter is the switching device. Uh, Maybe it could be a MOSFET, and there is an inductor here, and there is a capacitor. The value of the inductor is related with the ripple of the current flowing to the load, and also related with the input. Vs max is the maximum input, and then Vo is the output of the buck converter. And the variable f here is the frequency of the switching devices. The next is the capacitor. The output capacitor, it's related with the ripple voltage. To this, for the buck converter design, what we need is to we want to have the smallest ripple voltage, so that the ripple voltage usually is 0.1% or 0.001. The other technology that used in the solar charge controller is the MPPT. MPPT is the maximum power point tracking. Uh, this is a kind of algorithm that is used in a solar charge controller for extracting maximum available power from the voltage under a certain condition. So, for example, the output of the photovoltaic during maybe in the morning, at the 9, and the 12, or in the 15, the power output is different. But what we need to do is we need to check what is the maximum power that the power photovoltaic can output. This is the reason why we need to use the MPPT, so that we will have an efficient uh, we will have an efficient power for the solar charge controller. Next, the method behind the solar shelter is about the battery charging method. There are three variables uh, that is important for the battery charging method. The first one is the charging current. The charging current is related or adjusted to the battery capacity. So if we have the 50 ampere hour battery, then the amount of the charging current must be set between 10% until 30% of the battery capacity. So if we use a 50 ampere hour battery, then we choose 10% of the 50 ampere hour battery, then the output current of the buck converter should be 5. Yeah, should be 5 amps. And if we choose the 5 amps for the current, for the charging current, then we can estimate or calculate the charging time. The charging time is dependent to the amount of the charging current. So if the battery is 50 ampere hour and the charging is 5 ampere, then the charging time is 10 hour. To reduce the time, we can make a we can let the charging current bigger. However, it must follow the regulation that the charging current must be set between 10% to 30%. Otherwise, the battery will be damaged or offer uh, charging current. So the next is about the charging voltage. The So the solar charging controller also maintain the charging voltage for the battery. So for example, we have the 12-volt battery. Uh, each 12-volt battery has 6 cells that can be charged with 2.3 volt until 2.4 volt per cell. Therefore, for the 12-volt battery, uh, typically charged between 13.8 volt to 14.4 volt. So it can be obtained from 6 multiplied by 2.3 or 6 multiplied by 2.4. So usually for the 12-volt battery, it is charged by the 14.4 volt voltage from the charging controller. Okay, then next, after we talk about the charging process from the solar panel to the battery to store the energy from the total voltage to the battery, then now we are talking about the AC inverter system. So the basic idea is how to convert the DC energy to the AC electrical energy. So basically, in the inverter system, um, they use the boost converter. The boost converter here is used to convert the 12-volt voltage from the battery to a higher voltage as as the input of the single phase inverter. So the boost converter is a type of the DC-DC converter that efficiently increase the input voltage to a higher output voltage. output of the converter, as we can see in this equation, is the related with the input voltage divided by 1 minus D. So the output of the boost converter is always higher than the input. Similarly, with the buck converter, the boost converter has three components, three main components. The first one is this switching device, could be MOSFET or IGBT, and the second was in inductor. The value of inductor again is related with the ripple of the current flowing from the source to the load. And the third one is the capacitor output, the output capacitor. The output capacitor here is related with the duty cycle and also the voltage ripple and also the switching frequency. This is the main part of the boost converter and also the buck converter is in inductor, capacitor, and also the switching device. One more, we need a diode here. Okay, after we convert from the 12 volt voltage from the battery to the higher voltage, for example 12 volt to the 220, then we use the single phase inverter to convert from the 220 volt DC to the 220 volt AC. The single phase inverter convert the DC input into an AC output. So the main goal is to generate an AC output waveform that mimics a sinusoidal waveform with a little harmonic content. So usually the output of the inverter is not purely sine, but mimics a sinusoidal waveform. And usually we need a filter in the output side. The filter. And in here, the output is supposed to be 220 volt and 50 hertz. So in Indonesia, we use the 50 hertz for the grid. And as we can see here, the single phase inverter consists of the four switching device. The first leg, Q1 and Q0, and the second leg is the Q3 and Q2. And the first leg and the second leg, I mean that like Q1 and Q2 and Q3 and Q0, they are turning on and turning off simultaneously. Next one is about the DC low voltage system. So because in the solar shelter, we also provide the 5 volt USB socket. So that's why we need a buck converter again from the 12 volt battery, and then we need to reduce it to 5 volt. So in the low voltage system, a buck converter is used to convert 12 volt DC from the battery to 5 volt DC to provide energy to 5 volt socket. This is the basic principle of the solar shelter that we use in Gili, Iyang Island. So again, the principle is about the energy conversion, how we convert the energy from the photovoltaic or solar panel, and then we store the energy from solar panel to the battery by using a solar charge controller. And the idea about solar cell controller is the converter, the buck converter, and the MPPT. And after that, we need to convert it to the AC system. Uh, and we use the inverter from the battery to convert the energy from the battery to the AC system. And for the DC low voltage system, we use the buck converter to lower down the voltage from the battery to the 5 volt. I think that's all from my side mm, about the solar shelter. If you have any questions, you can ask me later on when you are in here. Okay, that's all from me. Thank you very much for the attention and then to hear the explanation here. I'm Mubarok. See you. Bye bye.